In earlier videos, we took a look at blood test data from Jerahimon Kimura, a super centenarian who lived until he was 116 years old. But note that Jerahimon's data is just N of 1. What does centenarian blood test data look like in a relatively large cohort? So in today's video, we're going to take a look at blood test data from the Hainan Centenarian study, which included 1,754 subjects that had a median age of 100 years, as shown there. And note that in terms of the gender distribution in this study, 28% of the more than 1,700 people were men and 72% were women. And this isn't an uncommon finding in centenarian studies, as many studies have shown that women are far more likely to reach centenarian status and beyond when compared with men. All right, so what about the blood test data? So 16 blood test variables were published in the paper. And in the interest of time, in part one, we're going to split this data up into two parts. So in part one, we're going to go over the first half, so 8 biomarkers, and especially all of these data that I'm going to present in the video are what's good. And in the second half of this series, I'm going to present data for the other 8 biomarkers, and we'll see what's good and what may be bad for these centenarians, for this more than 1,700 people who had a median age of 100 years old. All right, so jumping right into it, first let's start with FPG, which stands for fasting plasma glucose. And the data in the paper was presented in millimoles per liter. So to convert that into milligrams per deciliter, because not everyone's blood test data is presented in millimoles per liter, some people have it in that. Other people like me have their data presented in milligrams per deciliter. So we've got both values there. So in this study, how does glucose change with aging? So that's what's presented here in this study of almost 12.5 million people. So we can clearly see that blood glucose levels increase during aging for both men in green and women in red. So what about the centenarian median data of 83 milligrams per deciliter? Well, we can see that it's indicative of youth, as it's at the far left side of the graph. Well, what about all-cause mortality risk? So there's a J-shaped curve for all-cause mortality risk for its association with blood glucose levels. And we can note that the centenarian data is within the lowest range for all-cause mortality, which is 80 to 94 milligrams per deciliter. And note that as blood glucose levels increase during aging, correspondingly, we can see that all-cause mortality risk increases for relatively higher levels of glucose. So in terms of what's good, to start, we can see that these centenarians have relatively youthful and healthy levels of glucose. So second up is total protein. So how does total protein change during aging? That's what's presented here. And note that the units for this data is in grams per deciliter, whereas in the centenarian study it was in grams per liter. So to convert the units, we would divide grams per liter by 10 to get 7.03 grams per deciliter. So total protein declines during aging from values of about 7.4 in both men in green and women in blue, towards values that are in the 6.6 to 6.8 range for men and women respectively. So when plotting the centenarian median data for total protein of 7.03 grams per deciliter, we can see that that would put them in the 60 to 70-year-old range, which is 30 to 40 years younger than expected based on their chronological age, with a median age of 100 years. Now, note that total protein includes albumin plus globulin, and albumin data was presented in the paper, as shown there. So let's put that data into perspective. So here we're looking at serum levels of albumin on the y-axis plotted against age. And in this study of more than 1 million people, the age range went up to 100 years. So we can clearly see that albumin levels decline during aging for both men and women, with peak values in men of around 46 grams per liter and for women around 45 grams per liter. So when putting the centenarian median albumin on this plot of 40.5, we can see that they've got 20-year younger albumin levels than expected based on their chronological age. So they've got the albumin levels of about an 80-year-old. So in terms of what's good, from these data, we can conclude that they've got relatively youthful levels of total protein and albumin. What about the association for all-cause mortality risk with albumin? And that's what's shown here. So the hazard ratio for all-cause mortality on the y-axis plotted against the albumin concentration on the x. So first note that lowest all-cause mortality risk is when albumin is 46 grams per liter in this study of more than 425,000 people. And I'll have all of the papers referenced in this video in the video's description. So putting the centenarian median data on this plot, we can see that their 40.5 is a little bit far from lowest all-cause mortality risk, as they have a significantly increased all-cause mortality risk based on their albumin data. But note that for their chronological age of 100 years, we'd expect to see albumin levels of 36. So when we put that data on the all-cause mortality plot, the centenarian median value of 40.5 is 75, would impart a 75% lower all-cause mortality risk when compared with their age expected albumin level of 36. So from these data, we can conclude that they not only have relatively youthful levels of albumin, they also have a significantly reduced age expected all-cause mortality risk, ACM risk, for albumin. Now, note that we can rearrange the total protein equation to calculate the globulin concentration, which equals total protein minus albumin, and it's been referred to as the gamma gap. So total protein minus albumin not only equals globulin, but it's also referred to as the gamma gap. So how can we put this globulin data of 29.8 grams per liter into perspective? And I presented this data before in the Jarahiman video, so if you missed it, here'll be a good chance to catch up on that data. So here we're looking at survival probability on the y-axis. So baseline levels of the gamma gap or globulin levels were assessed at baseline, and then survival was evaluated up to 5 years after the baseline visit. And we can assess median survival by looking at the 50% survival right there for both people who had a gamma gap less than 3.2 grams per deciliter, which is indicated in blue, and greater than 3.2 grams per deciliter, which is indicated in red. And again, to convert the globulin data of 29.8 grams per liter to grams per deciliter, we divide the grams per liter by 10 to get 2.98. Now, note that this study was in 94-year-olds, which is relatively close to the centenarian median age of 100 years old. All right, so when going back to the 50% survival, when looking at people who had a relatively high gamma gap, when compared with people who had a relatively lower gamma gap, less than 3.2 in the blue line, these two, survival was significantly improved in people who had a lower gamma gap when compared with people who had a gamma gap that was greater than 3.2. And you can see that based on the log rank p-value of p-value less than 0.27. So from this, by putting the centenarian median gamma gap or globulin data onto these curves, they had a 2.98 grams per liter value, which would put them on the blue curve, which had a significantly improved survival when compared with relatively higher globulin levels. So in terms of what's good, we conclude from this data that they had relatively healthy levels of globulin. All right, so moving right along, SCR, and that stands for serum levels of creatinine. And creatinine is generally measured as an indicator of kidney function, with one measure of kidney function being the eGFR, the estimated glomerular filtration rate. So those values, serum creatinine in this case was used to derive the eGFR, which we can see is 59.8, so close to 60. So let's put that data into perspective. So here we're looking at the GFR estimate, or eGFR, plotted against age, and we can see that eGFR declines during aging for both men in green and women in blue. From values of about 125 in youth, to values for eGFR approaching 50 in people older than or about 95 years old. So when putting the centenarian median eGFR data onto this plot, we can see that would put them for someone who was about 65 years old, which is 35 years younger when compared with their age expected eGFR. But note that creatinine may not be a good marker of kidney function in people older than 65. And for that analysis, I'll link to the video right there in the right corner. So note that blood levels of uric acid and urea can further contribute to kidney function assessment. So first, let's have a look at the uric acid data that was presented in this video, and that was indicated by SUA, or serum levels of uric acid. So let's put that data for uric acid into perspective. So here we're looking at the all-cause mortality risk on the y-axis plotted against the uric acid concentration on the x. And we can see that lowest all-cause mortality risk is associated with uric acid levels of 303 micromolar. So what about the centenarian data? How does that fit onto this plot? Well, the centenarian median uric acid level was 326 micromolar, which is very close to the lowest risk for all-cause mortality based on this plot. So from this, we can conclude that they have close to optimal uric acid levels. So in terms of what's good, these centenarians of more than 1,700 people have younger than expected kidney function and relatively healthy levels of uric acid. All right, so what about serum levels of urea? So here's a plot for blood urea nitrogen, which is the same measurement that was reported in the paper for serum urea, and how it changes during aging. And we can clearly see that blood urea nitrogen bun increases during aging for both, again, men in green and women in blue. So to put the centenarian data into perspective with their blood urea nitrogen of 16 milligrams per deciliter, that would put them in the 60 to 70-year-old age range, which is 30 to 40 years younger than what you would expect bun levels to be based on their chronological age. So what about all-cause mortality risk and blood urea nitrogen levels? And that's what's presented here. So first, note that lowest all-cause mortality risk at the bottom of that U curve is present when blood urea nitrogen levels are 5.26 millimolar or 14.7 milligrams per deciliter. So the Centenarian data is very close to that, as you can see, with their value of 16 milligrams per deciliter. So they've got close to optimal bun. So in terms of what's good, these centenarians have younger than expected and relatively healthy levels of bun. And note that collectively, these three markers, creatinine, uric acid, and urea, suggest good kidney function in this centenarian cohort. All right, so two more biomarkers in this video. Triglycerides, TGs, let's put that data into perspective. So this is data for a meta-analysis of 61 studies that included more than 700,000 people. And we're looking at all-cause mortality risk plotted against the triglyceride concentration on the x-axis. And what we can see first is that triglycerides, as triglycerides increase, all-cause mortality risk also increases, as indicated by the red line. And note that triglycerides of 90 or 1 millimolar is associated with the lowest risk for all-cause mortality, all the way to the left. Now note that the Centenarian data for median levels of triglycerides was 1.1 millimolar, which is very close to the lowest risk on this plot of 1 millimolar. So in terms of what's good, these centenarians have relatively healthy levels of triglycerides. And as I mentioned in the Jarahiman video, relatively low levels of triglycerides may be a hallmark of longevity. So here's data for 11 centenarian studies. You can see by the average age for the participants in these studies was at least 100 years old in each of these 11 studies. And I'll put the link for all of these 11 studies, which is on a link on my website that included all these 11 studies. So if you're interested in that, check out the video's description. So note that in 9 of these studies, and note that this study that we're going over now in the video is not included on this list. So this would be study number 12. In these 11 studies, 9 of these 11 studies, triglycerides were lower than 101 milligrams per deciliter. So now this is 10 of 12 centenarian studies where triglycerides are relatively low, so less than about 101 milligrams per deciliter, which suggests that the relatively low triglycerides may be a hallmark of longevity. All right, and then last but not least, HDL. So we can see their data here, 1.4 millimolar, 54 milligrams per deciliter. Let's put that data into perspective. So first, age-related changes for HDL. We can see that HDL peaks in youth for both women and men. For women, about 64. For men, with a peak of about 56. And then HDL declines during aging pretty steadily for women, as shown there by the red line. And then for men, there's also a decline for about 10 years, after which it's relatively stable, but you can see it's at a lower level. HDL is at a lower level almost exclusively for the duration of the lifespan when compared with women. So the centenarian median HDL was 54 milligrams per deciliter. So let's put that data into perspective on this graph. So for women, we can see that it would be for an HDL expected a value of about someone who is 74 years old, so that's 26 years younger than expected based on chronological age. And a HDL of 54 would be even younger for men. We can see that it would we would expect to see that value for a man that was 18 or 28 years old, as indicated by the 2 black dots. So from these data, we can see that there's a 26 to 82 year younger HDL than expected based on a 100-year chronological age. What about all-cause mortality risk? And that's what's shown here. So we can see that based on the centenarian median HDL of 54 milligrams per deciliter, that would put them right at the bottom of that all-cause mortality risk. So lowest risk for all-cause mortality based on their HDL data. So in terms of what's good, these centenarians have relatively youthful and healthy levels of HDL. All right, that's the first 8 biomarkers that were presented in this paper. Stay tuned for part 2, the other 8 biomarkers, which will be coming soon. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. Thanks for watching. I hope that you enjoyed the video. Have a great day.